All right, hello students. The last video was about an introduction to parabolas and talking about translations. Today's video is the second part of that. I'm going to go back over how to tell whether it's a min or maximum point more specifically, and how to find the x and y intercepts both algebraically and by graphing. So I'm again going to use the notes to guide me. So if you want to get those out, you can. Otherwise, you can just watch and enjoy the sound of my voice. Okay, so this is your page 65, I believe, in your note package. And last class we talked, or last lesson I should say, we talked about this format, and it's called vertex form. And if there's a number in the A position, that tells us whether it's going to open up or down. So if it's positive, it's going to open up, and if it's a negative number, it's going to open down. The opposite value of P, so if it says -5 here, that means it's going to move 5 in the positive direction. And if it says +7 here, it means it's going to move 7 in the negative direction. So this tells us whether it goes left or right. It will go left in the negative direction if the number is positive, and it will go right in the positive direction if it is a -P. And then this number right here will tell us whether it moves up or down, not whether it opens up or down, whether it actually moves up or down on the graph. And of course, if it moves up, it's a plus Q, and if it moves down, it's a minus Q. So let's look at this data here. Okay, so the minimum maximum point says graph y equals x minus 4 squared minus 3. So you can do this by making a table of values like we did in the last question. You can also graph it quickly using a program on your by using a graphing calculator and by using different apps on your phone. I'm going to show you one of those apps shortly on what you can do, but in the meantime, with the exception of those materials or the tech, you can just graph, make a table of x values, calculate what y will equal when x is 0, when x is 1, when x is -1, just like we did in the last graph. So from this graph, I can tell a couple of things right away. Do you see how there is a value of, it says -4 there? Remember, the p-value is the x value of our vertex. So it's going to happen at +4, remembering that the p-value, because it's -p, it's the opposite sign. And our q value tells us the value of the y part of the coordinate for the vertex. So if it says -3 here, that means the vertex happens at -3. So if we go over 1, 2, 3, 4, and down 3, 1, 2, 3, our vertex is here. And that's supposed to be down 3. It doesn't look like it, does it? All right. I don't know what happened there. I think instead of deleting my actions, I made new pages. That's awesome. Okay, so 1, 2, 3, 4, 1, 2, 3, here's our vertex. So sometimes it really helps figuring that out right away, because then you can figure out what values you want to put in your table of values. And they kind of have to center around x being 4. So you would try x being 4, 5, 6, and maybe 3, 2, and 1, and that will give you the values. So I'm just going to put those values on, 1, 2. And what's kind of nice is when you find the values on one side of the parabola, and you know where the vertex is, you know that the other side is just going to mirror the one side that you find. So you don't even need to find both sides by a table of values, as long as you know where the vertex is. So again, I found the vertex because the number here was -4. So remember, we take the opposite sign because it has to be a +4 that goes in for the p-value for it to stay minus 4 there. And I found the y portion of the coordinate, of the vertex, by what the q value was. In this case, it was minus 3. Okay, so the other thing I wanted to just point out from yesterday's lesson as well, or last lesson, was that the axis of symmetry goes straight through the vertex, and it's always what x is. No matter what y is, x is always going to be the same value, and that's the same value as the x portion of the coordinate. So if you're seeing, I'm just summarizing the last lesson. Oops, that was the wrong color. So our vertex became 4, our axis of symmetry of 4. And because the number in this position, oops, that wasn't very, there, right here, there's no number, so that means there's actually a positive 1 there, and it's positive. So that means that our graph is going to open up, in which, of course, we've already seen that it does. Okay. The domain x is all real numbers, always. The only time that will change is if there's a specific problem you're trying to solve for and there's additional restrictions put on the solution. Is this a minimum or maximum? Can you have a value below this point right here? Can you have something below this point? Can there be a value for y below this point that's going to fall on that parabola, which I've done in blue? Is there anything below that point? And the answer is no. So that the minimum most point is the y coordinate of the vertex. So this is a minimum. And the range is y has to be larger than or greater than -3. Okay. So pause the video here and see if you can do the next one that has these joint things together. Okay. So welcome back. We are going to do, again, a table of values. You can do that on the side. You can do that on your own. You can put it in a graphing calculator, or you can put it in an app on your phone. All right. So you're gonna find where the vertex is right away from the equation. This is +6. That's going to give us the vertex, and it's going to give us the equation for the axis of symmetry. Okay. It says +6, so that means the vertex happens when x is at -6, because it's -6 that resulted in it saying +6 right here. Okay, so it's actually -6, and that means our axis symmetry is when x equals -6. So 1, 2, 3, 4, 5, 6. Here's where x is -6. Here's our axis of symmetry. Our vertex has to fall somewhere on that line. And we've been given the whole equation, so we actually know where it falls on that line, because the number in the cube position of that format is +4. So that means that the vertex happens when x is -6 and y is +4. Oh, I don't know what happened right there. That's not what I wanted. I'm just going to leave it red. All right, so here we go up 1, 2, 3, 4, and here is our vertex. Okay, that's at the coordinate where x is -6 and y is 4. The direction of the opening we get from the value, from the sign of the number in the A position. So we have to look at the number in the A position. Okay, there is no number there, which means the number is 1, and there's a negative sign there, which means the number is actually a -1. So when the number in the A position, which I've highlighted in purple there, is negative, the parabola is going to open downwards. Okay, so it's going to open down. That's when you would start doing a table of values with x equaling -6 as your central number. So you would pick x equals -8, -7, -6, 5, 4, 3 and get your values, you'll start to kind of see a pattern to 1, 2, 4, 3, 1, 2. And here's our parabola opening down. I'm just sketching it. Lovely. All right, so what is the domain? X can be any real number. The range is the value of, you know, it has something to do with this number here. It says positive 4. So that means the range has to do with the y values. Remember, domain has to do with x and range has to do with y. D comes before r, x comes before y. So it's one way of remembering it that way. So you know it has to do with 4. Because it's a maximum, it can't be above this value. That means y has to be less than or equal to 4. Okay. And I meant to put has a max value. The maximum value, y value of 4 occurs when x equals -6. So really, I'm just trying to re-go over and re-emphasize and put together everything that we learned in the last lesson. Okay, so you get these values that I've highlighted in yellow and blue from the original equation and the numbers in that original format. What I'm going to cover now is how to find the x-intercepts algebraically and by graphing. Okay, so x-intercepts are where the graph crosses the x-axis. The value of the y-coordinates for any of the x-intercepts is always 0. So the x-intercepts happen when y equals 0, and you're always trying to find what does x equal. Okay, so on the graph, we can see that one of the x-intercepts is right here. So you see that red line is the parabola, and it's intersecting right the x-axis right here at -1. So from graphing, we can tell that x equals -1. And we can tell there's actually 2 because it actually crosses the x-axis in 2 places. So it crosses here as well. So x can also equal +3. And those are the 2 x-intercepts. And that's lovely. And it's lovely because it's easy to read off the graph and we don't have to do any algebra to find it. The problem with it is that unless you're provided the graph, you're going to have to graph and hope that you're graphing it accurately. And not all x-intercepts intercept exactly at a nice, healthy integer. You know, sometimes they're off of the little grid lines and you can't read exactly what it is. And part of Pre-Calc 11 is all about how to get numbers while maintaining precision. Okay, so there must be a way to algebraically solve, and there is. So algebraically, we can solve for x. We set y to be equal to 0 because that's the value of y at those x-intercepts, and we're going to solve for x. Okay, so here is the equation for that line. It says y equals x minus 1 squared minus 4. So we're looking for the value of x when y equals 0. So we put a 0 in for y. Okay. So we're going to move that -4 to both sides and rewrite. So we get 4 equals x minus 1 squared. Now currently that bracket is being squared. What's the opposite of squaring something? Square rooting. So you're going to square root this side and you're going to square root this side. Now the square root of 4 actually has 2 possible solutions. It can be +2, but it can also be -2. And your calculator is only going to give you the positive version. But technically, -2 is also the square root of +4, because -2 times -2 is +4. So there's both those possibilities, okay? Which is why the parabola has two sides. So this is going to equal x minus 1. Okay? So the next thing you have to do is get rid of that -1 because we want x by itself. So you're going to add 1 to both sides. Okay. And I'm just going to move the next part up here. So you have 1 plus or minus 2 equals x. So this is where you have two possibilities. And so you kind of split it apart. You can have x equals 1 plus 2, which means x would equal 3. And you have x equals 1 minus 2, in which case x will equal -1. So algebraically, x equals -1 and 3. And because we had the graph provided to us, we had the same answers that we found by graphing, okay, by reading it off of the graph. So pause the video here and try the next one. So if you try to do it by graphing, you would have noticed that these x-intercepts are kind of, so you can't really tell by graphing. So by graphing, x equals, I don't know, it's somewhere around 1, 2, 3, negative 3.8-ish. And I would say 5, 6, 7, 8, around negative 8 point, I don't know, 2-ish, around there. And that's me guesstimating just by looking at it. All right, so now we can solve it algebraically. So remember, to solve it algebraically, we are going to set y to equal 0, and we're going to solve for x. Okay, so 0 equals x plus 6 squared minus 5. Our first step is to add 5 to both sides. Okay. So we get 5 equals x plus 6 squared. The next thing we need to do is square root. Oops, I went yellow that time. I had to stay with red, but it's okay. And then we're left with plus or minus the square root of 5. We're going to maintain precision. We're going to leave it as the square root of 5, because if you put square root of 5 in your calculator, it's a hot mess number. It means it's an irrational number. It's not very pretty. And if we were to round it off now, we would lose precision. Sometimes we do have to round off the answers, but remember, we want to do it that at the very end. Okay, so it's plus or minus square root 5 equals x plus 6. Now the opposite of adding 6 is to subtract 6. So you're going to subtract 6 from both sides. Okay. So we have -6 plus or minus the square root of 5 equals x. So again, there's two possibilities. We have where x equals -6 plus the square root of 5. And we have x equals -6 minus the square root of 5. Now, if I asked you for an exact value, and I want the exact value of the x-intercept, you would leave it like that, because that cannot be simplified. -6 and the square root of 5 are not like terms. They are not like radicals. You can't add them. You can't multiply them together. You just have to leave them like that. The square root of 5 is already a simplified mixed radical. It cannot be simplified further either. So that would be your answer. If you were to plug it into your calculator, you would get an answer around -3.8, and you would get an answer around -8.2. Okay. So my guesses were actually pretty on, and that's not too bad. But you would know they were somewhere around there. So if you guessed 3.9 and 8.1 or 3.7 and 8.3 or things around there, you would know that your answer was correct, because you can ballpark it by looking at the graph. All right. So now I'm going to look at the y-intercepts. The y-intercepts, the value of the, okay, so I was just having a moment. The value of the x-coordinate for any y-intercept is always 0. So this is when x equals 0, and we want to know what y equals. Okay, so on this graph we did before, these are the x-intercepts right here and here, but we want to find the y-intercept. And there's certain reasons why we want to find these values of interest, but right now we're just going to focus on the mechanisms of finding them. So we need to find what the value is when x is 0, what does y equal? All right, so by graphing on this one, we can tell from the graph, we can count down at 1, 2, 3. Oh, by graphing, I can tell the answer that y is equal to -3. That is the y-intercept. I can read it off the graph. Lovely. Sometimes you're not going to have a graph provided to you. Sometimes you're going to have to construct the graph. And sometimes the value for the y-intercept is not going to be a lovely integer where it falls nicely on a grid line that you can read off of. Constructing a graph manually, as you've probably figured out, takes time. You've got to take a table of values, you've got to plug numbers in, you've got to calculate them, you might make a mistake. And again, there must be a way to find this out without having to bring out some graphing paper and graph it. And that's when we're going to solve it algebraically. So algebraically, we want the value of y when x is 0. So we're going to set x equal to 0, and we're going to solve for y. And the lovely thing about this one is y is already solved for. It's y equals x minus 1 squared minus 4. Y is already isolated. There's no algebra technically in there. This is just actually straight BEDMAS, straight calculation, where we're just going to follow the proper order of operations to get our answer. So I'm going to rewrite this, but instead of writing x, I'm going to put a 0 in for x. Okay. Order of operations is BEDMAS, or PEDMAS, or PEMDAS, depending on if you're French immersion or not. And so we're going to simplify. We're going to do the stuff in the brackets first. 0 minus 1 is -1. Okay, so we did our brackets first. Next is exponents. -1 squared is +1. We don't have any division. We don't have any multiplication. We don't have any addition. We're going to do a subtraction next. 1 minus 4 is -3. And we've already looked, because we have the actual graph accompanying this, we can tell that we are correct. So pause the video here and try that next one. Okay, so to solve it by graphing, can you solve it by graphing? No, not if this was the graph provided to you. You have the equation, you could stick it in a calculator or a phone app and find it, but sometimes it's actually much faster and much more precise to solve it algebraically. So algebraically, we are going to set x equaling to 0, we're going to set the x to equal 0, and we're going to solve for y. Okay, so the equation is y equals x plus 6 squared minus 5. We're going to set x equaling to 0, so we're going to put a 0 in for x. Okay, we're going to do this stuff in the brackets first. So 0 plus 6 is 6. We're going to do exponents next. So 6 squared is 36. And then we're going to do our subtraction last. 36 minus 5 is 31. So that is our y-intercept. Y equals 31. And that kind of fits with what we're seeing on the graph, because we know that this is going to keep going up a long way and is definitely going to be more than 15. So having it as a high number like that fits with what we're seeing with the graph provided. Okay. So this last example is a word problem. It says the parabola y equals x squared is transformed as described below. its image has the form of this. That's just the vertex form that we've been learning about. Determine the values for A, P, and Q for each transformation and write them in the form y equals A times x minus p squared plus q, or minus p. Yeah, I said it right. All right, so pause the video here and see if you can figure this one out on your own. Okay, so remember when I went over this? A is if it goes, opens up or down, P is left or right, and Q is whether it moves up or down. Okay, so if it moves 7 units to the left, that means it's the p-value is going to have to be a positive p-value to go into Q because it's moving in the negative direction. So y is going to equal x plus 11 because it goes in the negative direction. So that means what we see in the actual formula is a plus 11. It moves 4 units down. So that means that Q here has to be minus 4. So that means it's minus 4 here. And then it says it opens up. So opening up has to do with the sign of the number in the A position. And that A position needs to be positive. And sure enough, it's already positive. So we just leave it like that. And that is our answer. I'm just going to actually write a positive in there so you know what I'm talking about. It's that location there. But we don't actually have to write the positive symbol because lazy mathematicians. Okay. So pause the video here and try B. All right, welcome back. So y equals, it says it opens down, so that means the number in the A position has to be negative. We haven't talked about what the effect of A being a number other than 1 is yet. That's next lesson. We know that it moves 9 units to the right, so to the right is in the positive direction, which means we're going to have a minus 9 in the brackets. And it goes 13 units up, so that's the Q value, so it's going to be a plus 13. I hope that's the answer that you got. I have attached a lesson 1 handout for the section. I hope that this video helped. If you have any questions, please let me know. And thank you for joining me and have a great day.